In Lesson 9.2, we're looking at translations. You'll learn how to draw translated images using coordinates and draw translated images by using repeated reflections. How are translations used in a marching band show? The sights and pageantry of a marching band performance can add to the excitement of a sporting event. The movements of each band member as they progress through the show are examples of translations. A translation is a transformation that moves all points of a figure the same distance in the same direction. Translations on the coordinate plane can be drawn if you know the direction and how far the figure is moving, horizontally and/or vertically. For the fixed values of a and b, a translation moves every point p of xy on a plane figure to an image of p prime x plus a, y plus b. One way to symbolize a transformation is to write xy translates to x plus a, y plus b. Parallelogram TUVW has vertices at negative 1, 4, 2, 5, 4, 3, and 1, 2. Graph TUVW and its image for the translation x translates to x minus 4, y minus 5. Well, they gave us the rule. All we have to do is take each of our x coordinates and subtract 4, take each of our y coordinates and subtract 5. Now, I would not suggest writing that out, but it's good to see what they're doing for one time. I'd be more likely just to jump right to this last step, just like we did in the last lesson. So you can see in the graphs that each point has moved 4 units to the left and 5 units down. 4 left, 5 down. The graph shows the repeated translations that result in the animation of a raindrop. Find the translation that moves raindrop 2 to raindrop 3, and then the translation that moves raindrop 3 to raindrop 4. Well, from 2 to 3, I'm moving 2 units to the left, and it looks like 3 units down. So to go 2 units to the left, I need to take 1 minus 2 to get to negative 1, and to move 3 units down, I need to take the y value, which was 2, and subtract 3 to get to negative 1. And then we want to do the same thing from 3 to 4. So it looks like from 3 to 4, oh, we're not moving right or left, we're just moving 3 units down. So I'm going to leave my x alone, and I'm just going to subtract 3 from y. Another way to find a translation is to perform a reflection in the first of 2 parallel lines, then reflect the image in the other parallel line. The transformation made up by successive transformations is called a composition because it's composed of more than one transformation. For our last example, they want us to determine whether the pink figure is a translation image of the blue preimage. In order to be a translation image, it said here we were supposed to reflect. Okay, so we're supposed to perform a reflection in the first of 2 parallel lines. So first they wanted us, because this has 1 tick mark, we're supposed to reflect the blue over P. And so if it were reflected, it should be like that. So this is going to be a no, because it's not a reflection. The second, the whatever that is, purplish violet, is a reflection of the green, but they'd have to both be reflections. So not a reflection. In summary, a translation moves all the points of a figure in the same distance in the same direction. A translation can be represented as a composition of reflections.